Good morning. All right, so we are now starting quarter two. We're going to go into more in-depth analysis of Pythagorean Theorem, and in particular for today, we're going to focus on 30, 60, 90 triangles, and then tomorrow we're going to go over 45, 45, and 90 triangles. Now right here is your little cheat sheet, because first things you got to know is we always use Pythagorean Theorem to find one missing side length when given two. Okay, and that's always work for all right triangles for Pythagorean Theorem. But now in these particular cases, there is a way to figure out two missing side lengths when given one. In particular, when I'm working with a 30, 60, 90 triangle. Now here's your cheat sheet. This is considered my short length, okay? This is call this your short length, okay? Whereas this is my long length, and this is your hypotenuse, all right? Which I call it height for short, okay? Your hypotenuse is always going to be 2x, or the way if you want to just memorize it, and I hate to use that word in math class, it's your length between your 60 and your 30 degree angle. Your length between your 60 and your 90 degree angle is always considered your short length. This is always your x, and this is your long length, the side between 90 and 30. That's always going to be your x radical 3. Now let's prove this true and show you why we figured out this format in the first place. Well, a 30, 60, 90 triangle is simply an equilateral triangle that is cut in half, just like such, okay? Now, how do I know this? Because if this is 60, this is 90, 60 degrees here, because all equilateral triangles are 60, 60, 60, okay? So to prove it true, I'm just showing you like how we know this is always true. If I have an equilateral right here, which has all lengths are 6, okay? Well, we already know what this is. So now if I'm taking this little triangle right here that I just cut up, okay? Right there. I know this is my 90 degree angle. This has to be my 60 degree angle. That's the left corner of my triangle. And I cut 60 degrees in half, so clearly this is my 30 degree angle. Now let's prove that this is true. And this will always work, guys. So for instance, I already told you that this length here is 6, okay? Well, according to our rule, when I know my hypotenuse is 6, that's 2x, well, this is going to be half of this. So just take half of this, and this is 3. Well, this is supposed to end up as, if x is 3, this is supposed to end up as 3 radical 3. But let's prove that true to show you that this actually is how it simplifies down. So I'm going to have 6 squared equals 3 squared plus, let's call this x squared, because we don't know what this length is yet, even though we know it's going to end up just like this. So let's do this. So 36 equals 9 plus x squared. We can all see this, I think so. All right. That's 36 equals 9 plus x squared minus 9 from both sides. Now I'm going to get 27 equals x squared. And then I simply square root. Now this is why it was so important to know how to simplify radicals. I know that my 27 has a 9 and a 3 inside of it. The 9 comes outside as a 3. So your final answer for x is x equals 3 radical 3. Now, because I'm working with a 30, 60, 90 triangle, I don't have to go through all this work. I just did this to show you, to prove to you, that now we know that this in fact is true. And I told you, when you know x, it's just x radical 3. If you know what x is, you just multiply x by 2 to get your hypotenuse. And just in the opposite way, we went backwards. So I divided by 2 to get 3, and then I just did this. This is 3, so now this is 3 radical 3. I'll do a couple more examples for you, just to give you a little head start on what we're doing this week. Okay, so here we go. I got a couple of examples for you right here, and these are going to be easy, medium, and hard. And I wrote these out of order, so I'm going to do 1, then 3, then 2, just to show you how to go through this, okay? First things first, I'm given 72, and I got to look and think, okay, what is this between? This is between my 30 and clearly my 60. Between my 30 and my 60 is my 2x. Sometimes I want to go in there and actually write down all my angles so I know what goes where. That's a good idea at first, guys, when you're first doing this. So I know I can easily and quickly find this length because this length is half of this length. So then this is going to be 36, all right? And then real quick, because remember I took half of this to get this, well this is just whatever this is, radical 3, because this is x. So now it's just real quick, this is going to be 36 radical 3. And you can do the Pythagorean theorem to figure all that out, okay? Now this one, a little more thought and effort on this one, so clearly this is right between my 30-degree angle right here, all right? So I know my length between my 30 and my 90, okay? So this is where this gets a little tricky, okay? So now I know what this is. So if this whole length is equal to x radical 3, I gotta solve for x. And now this is where it gets confusing, because now this is a number. If this was just a number radical 3, it would be so easy, because then I put that number right here, because that's all you do. But now the number is not in that, it's not in that format, because we know it's supposed to be equal to x radical 3. So make the equation. So here's how you do this one. Okay, so now 9 equals x radical 3. The goal is to solve for x. So now I'm going to take both sides, divide by radical 3, okay? So now 9 over radical 3 equals x. Now remember what we learned in the last investigation. I cannot have a radical in my denominator. So I must multiply out my radical 3 of both. So now this says 9 radical 3 all over 3 equals x. Well, we're almost finished, because this still simplifies. 9 over 3 simplifies to 3 over 1, or just 3 radical 3. So 3 radical 3 equals x. So remember, now this is your x, so now this length right here is going to be 3 radical 3, okay? We're almost done, because now the simple part, we can solve this one of two ways and make sure we're doing this correct. I know that I'm just going to take this, well, let's prove this out, okay? Let me erase this, pause this, take notes on this, but remember, there's a lot of moving parts on this one, skills that we went over last investigation. Now we're going one step further. So I'm going to use the Pythagorean Theorem. I'm going to use the Pythagorean Theorem to solve for this side right here, but then I'll show you a quicker way to do it, okay? Remember, this is my A, this is my B, this is my C. So literally we're doing 9 squared plus 3 radical 3 squared equals c squared. Now when I got a power, this goes to both this number here and this number here. So 9 squared is 81 plus, well, this is going to be 3 squared is 9. Radical 3 squared is just 3 equals c squared. Well, this is 27, so this is 81 plus 27 equals c squared. And 81 plus 27 is 108 equals c squared. Now, let's simplify this all the way down. Do the math with me real quick. I'm going to get my calculator out. I'm going to divide 108 by, let's try 16. Divide by 16, that doesn't work. 108 divided by 9, I know that's going to work. So if I did that, I got 912. So let's do 108 divided by 36. Ooh, that's better. 108 divided by 36 is 3. So I got 36 and 3. So my C is actually going to equal 6 radical 3. This is going to be 6 radical 3. Or instead, and I did this to prove that this will always work, remember, this is my short leg, my hypotenuse is 2 times the short leg. So you simply just multiply this coefficient here by 2 to get this. That's the quick and easy version way to do it, but I want you to understand the why. All right, now let's do this one. Pause, take notes, ask questions today in class. We'll go through everything. Let's do number 2. So, get that up for you. All right, now given this length right here is 13 radical 3, so this is my short leg right here, and like we just proved, this is really simple to find this length right here. We just multiply this coefficient by 2, and this is going to be 26 radical 3, okay? Now, we got to solve for x. I'm going to use the same thinking theories on this one. I know that this length right here is equal to x, right? So I know that x is equal to 13 radical 3. Well, this says right here that this is supposed to be x, right? Radical 3. So if I'm replacing x with this expression in place of x here, this is going to say this. 13 radical 3 times radical 3. Because remember, this is saying x times radical 3. So I'm just replacing x with this given information right here. And now I'm carrying this out, and I'm going to prove that this is true. Well, this says radical 3 times radical 3, which is 3. So this ultimately says 13 times 3, which is 39. So let's prove that this length right here is equal to 39, and I'll prove that true by using the Pythagorean theorem. So here we go. I'm going to do a squared plus b squared equals c squared. So 13 radical 3 squared plus b squared equals 26 radical 3 squared. Now remember, distribute to here and to here, to both terms on the inside. Okay. Now 13 squared is good enough because I actually know this. This is going to be 169 times 3 plus b squared equals, what is 26 squared? 26 times 26. This is going to be 676 times 3. Because don't forget, the radical squared is just the number under the radical. That's how we know that. So now let's do our math and get working on this one. So this is 169 times 3, and that's 507 plus b squared equals 676. Always take your time. Times 3 is 2028. I'm going to minus 507. Minus 507. I'm going to get 1521. So b squared equals 1521. So let's see what's going to happen here. All right, this one's taking a little while, a little longer than we thought, probably thought, but or let's just see if this is a perfect square. So 1521. Look at that. You take the square root of 1521, you get b equals 39. Boom. Look at that. We proved that that works. You're going to get a lot of practice with this today and tomorrow. This is really going to strengthen your skills of following the mathematical process for solving any kinds of equations, but now going one step further with these powers, these exponents, and all this stuff. I will see you guys in today's class to help you guys out.